If you have to wash the dishes before loading the dishwasher, who is really doing the work? Every manual says scrape, don't rinse. Most people rinse anyway. They don't trust the machine. A modern Energy Star dishwasher uses around 3.2 gallons per cycle. Older machines use 10 to 15 gallons per cycle. A few minutes of pre-rinsing at the tap can erase most of that saving. So you have an appliance that is supposedly smarter, greener, and more efficient than ever. But it only works if you do half the job first. And that hidden flaw runs deeper than you think. Stand at any kitchen sink and you will witness a highly coordinated, unpaid daily chore. We scrape, we scrub, and we carefully stage plates like industrial packers. A standard kitchen faucet flows at 2.2 gallons per minute. Running that tap for just 90 seconds to rinse a load of dinner plates consumes over 3 gallons of water. In those 90 seconds, you have personally run through more water than a modern, energy-efficient dishwasher uses during its entire 3-hour cycle. Legally, those new machines are capped at 3.2 gallons of water. Older models gulp 10 to 15 gallons, blasting away food with sheer volume. Today's delicate, low water systems cannot handle that heavy lifting. To compensate, we have quietly been hired as the machine's manual pre-wash cycle. Appliance companies get the green efficiency stickers and the marketing glory, while we stand at the sink doing the actual physical labor. We are paying hundreds of dollars for a machine that only succeeds because we did the dirty work before the door even closed. This hands-on chore is a complete betrayal of why the machine was built in the first place. On December 28, 1886, Josephine Cochran secured United States patent number 355,139 for the first practical dishwasher. Cochran, an Illinois socialite, was tired of her servants chipping her heirloom china during hand washing. Her solution was a mechanical wheel that blasted hot, soapy water onto dishes using sheer water pressure, entirely eliminating manual scrubbing. At the 1893 World's Columbian Exposition in Chicago, 9 of Cochran's washers cleaned dishes in the fair's busiest restaurants, earning top awards for durability and utility. Commercial kitchens, hotels, and upscale restaurants quickly bought the machines because they replaced kitchen labor instead of demanding more of it. These early steam-powered monsters did not ask workers to carefully pre-rinse, scrape, or negotiate with delicate sensors. The machine's only job was to take dirty plates and make them clean. For over a century, the engineering goal was simple: replace human effort with mechanical force. The dishwasher was designed to be a servant, not a boss. Government efficiency standards fundamentally redesigned the modern dishwasher, narrowing its operating margins until there was no room left for error. In 2013, the United States federal standard capped residential models at 307 kilowatt hours per year and 5 gallons of water per cycle. By July 19, 2023, the Energy Star criteria squeezed those limits even tighter, demanding no more than 240 kilowatt hours annually and a mere 3.2 gallons of water per load. To earn the coveted green marketing stickers, manufacturers had to slash water and energy use to near impossible levels. But these paper savings required flawless internal performance. Operating on less water than it takes to flush a standard toilet leaves the machine with zero tolerance for bad loading, subpar detergent, or heavily soiled plates. The dishwasher is running on a mechanical tightrope. Because the appliance no longer has the raw resources to blast through mistakes, the burden of ensuring a successful wash shifts entirely onto the owner. Regulation explains why the machines became so delicate, but it is the consumer who pays for that efficiency in unpaid kitchen labor. Inside the tub of a modern dishwasher, there is no roaring flood. Instead, a tiny pool of just over 3 quarts of water sits in the sump. To clean a full load of dishes with this meager amount, the machine must operate as a highly calibrated, low-pressure hydraulic system. It pumps that same small puddle of water repeatedly through spinning spray arms, relying on precise angles, constant circulation, and exact water temperatures to slowly dissolve grease. Older machines simply blasted away mistakes with 12 gallons of scalding water. Today, there is no raw volume to compensate for a poorly placed bowl. If a wide plate blocks a spray arm's path, or if a coffee mug is angled slightly upward, the water path is physically cut off. The mechanical choreography fails instantly. Because the water volume is so restricted, the physical arrangement of your dishes acts as the actual plumbing system of the wash cycle. You are no longer just loading an appliance. You are manually configuring the machine's internal hydraulics. If you pack a rack too tightly, the water cannot physically reach the soil, leaving you to finish the job by hand. A parallel chemical crisis stripped the machine of its most powerful weapon. For decades, dishwasher detergents relied on phosphates to suspend minerals, dissolve grease, and prevent a cloudy film from settling on glassware. But what worked in the kitchen wreaked havoc on the environment. Runoff from household drains carried phosphorus into lakes and rivers, feeding massive algal blooms that choked aquatic life. By 2010, 17 states had restricted high phosphate formulas. Facing a fractured market, major brands like Procter & Gamble and Reckitt Benckiser phased out phosphates nationwide. Suddenly, machines had to clean with a much less forgiving toolkit. Without phosphates to soften water and carry away grease, consumers flooded product reviews with complaints of cloudy glasses coated with a white film. The chemical heavy lifting was gone, leaving the appliance vulnerable to hard water and minor loading errors. Instead of the industry re-engineering the machines, the burden shifted directly to the kitchen floor, forcing owners to manage water chemistry themselves. To replace phosphates, detergent chemists turned to enzymes, biological catalysts designed to target and digest specific proteins and starches. But these enzymes present a bizarre paradox. They need food to function. Without starches and proteins to latch onto, the active cleaning agents have nothing to target, causing them to wash away uselessly. This makes the simple act of loading the dishwasher a psychological game. Major manufacturers now issue highly specific, counterintuitive instructions. Scrape, but do not rinse. If you load a plate that is too dirty, the low water system gets overwhelmed. But if you load a plate that is too clean, the detergent fails to activate, leaving a cloudy film behind. The machine no longer just does the work. It manages the owner's choices. The actual cleaning cycle now begins inside your head as you stand over the sink, estimating the precise level of acceptable soil. We are left standing at the counter, trying to guess the exact amount of grime required to make an expensive modern appliance do its job. Modern dishwashers attempt to solve this guessing game using turbidity sensors like the Bosch AquaSensor or Whirlpool's sensor cycle. These devices shine a tiny beam of light through the water pooling in the sump, measuring how much debris blocks the light. Based on this turbidity reading, the machine's programming adjusts the cycle length, water temperature, and runtime. But this system has a fatal blind spot. It cannot actually see your dishes. It only knows what the water tells it. If you meticulously pre-rinse your plates, the water running into the sump stays perfectly clear. The sensor reads this clean water, assumes the entire load is pristine, and triggers a short, lukewarm cycle. Meanwhile, a dish with baked-on cheese on the top rack remains completely untouched. The machine cannot detect dried-on soils that refuse to wash off into the initial pool of water. By trying to help the appliance, your pre-washing has actively tricked its smart programming into doing less work. The ultimate irony of this high-tech system is that its intelligence relies entirely on the raw, unwashed honesty of your dirtiest plates. Number 17, meatloaf with tomato glaze and green beans. To keep these machines quiet, while running on a trickle of water, engineers made a quiet, physical trade-off at the very bottom of the tub. Older dishwashers were loud because they carried a miniature garbage disposal in their sump, a hard food disposer that actively pulverized food waste and flushed it down the drain. The machine made a racket, but it swallowed the mess. Today, if your dishwasher was purchased in the last decade, Consumer Reports notes it is highly likely to use a manual filter instead. To drop noise levels to a whisper, manufacturers quietly removed the disposal motor and replaced it with a plastic and mesh cup that simply sits in the drain. waiting. It does not grind, it collects. If you do not pull this slimy trap out and wash it under the faucet yourself, the consequences are immediate. Foul odors, stagnant water, and fine grit recirculating back onto your clean glasses. The engineering is clever, but the victory is hollow. The appliance did not actually get better at eliminating waste. It simply stopped doing the job, turning a mechanical function into a weekly household chore. In modern home design, the kitchen has merged with the living room. This open-plan layout transforms silence from a luxury into an absolute necessity. Appliance brands quickly realized that quiet sells. They began marketing whisper quiet machines operating in the 40 to 50 decibel range, turning decibel ratings into a primary showroom battleground. But silencing a dishwasher is not free. To drop the volume, manufacturers slowed down the water velocity, draped the tubs in heavy insulation, and relied on gentle, prolonged soaking rather than raw spraying power. The machine became socially polite by relinquishing its strength. It traded mechanical muscle for the prestige of silence, leaving you to compensate for its quiet, delicate cycle with extra prep work. The disappointment peaks the moment you open the door to find puddles pooling on the top of every coffee mug and plastic container. Older dishwashers dried everything by brute force, baking the interior with an exposed electric heating element. Modern energy standards killed that power-hungry cycle. Instead, high-efficiency machines rely on condensation drying, letting the hot, stainless steel walls draw moisture away. But this physical approach has a clear casualty: plastic. Polypropylene holds 5 times less heat than glass, cooling down too fast for water to evaporate. To get dry dishes, manufacturers now rely on rinse aid, turning a cosmetic extra into an essential chemical surfactant that forces water to sheet off. If you skip the liquid, the machine's energy savings are paid for with a dish towel in your hand. Even with flawless maintenance, every modern dishwasher eventually runs headfirst into a calculated economic wall. Major manufacturers and consumer reports peg the useful life of these machines at roughly 10 years. When a component fails near this decade mark, the machine does not need to be broken beyond repair. It only needs to be expensive enough to make fixing it feel completely irrational. Replacing a failed pump or motor assembly in the United States runs between $400 and $600. In the United Kingdom, a pump replacement averages 140 pounds, while a motor repair climbs to 255 pounds. Against the cost of a brand new appliance, the math does the work. Ownership turns into a cold, financial calculation, and another appliance heads straight for the landfill. Walk into any appliance showroom, and the marketing trap is immediately clear. Manufacturers spend heavily on superficial premium signals to distract from the cheapened mechanics underneath. They sell us on brushed, stainless trim, sleek touchscreens, hidden controls, and Wi-Fi enabled apps that send push notifications to our phones when a cycle finishes. But a phone alert cannot wash a plate. These decorative details command massive price markups while hiding the exact same fragile, low-water components found in budget models. True appliance value does not sit on a glossy control panel. It lives in the physical movement of water, heavy-duty rack wheels, easily accessible manual filters, robust leak protection, and a modular layout designed for straightforward repairs. We must stop paying extra for features that do not move water. On March 1st, 2021, the European Union implemented eco-design regulations to fight appliance waste. Under these rules, manufacturers must keep spare parts like hinges, seals, spray arms, and racks available for 10 years after a model is discontinued. Professional technicians must have access to critical components like pumps, motors, and heaters, along with official service manuals for at least 7 years. The law also mandates delivery within 15 working days. This provides a blueprint for the right to repair movement, proving that policy can legally push back against planned obsolescence. Yet, this safety net contains a major loophole. While the law guarantees that a replacement pump will exist on a warehouse shelf, it does not regulate the price. A manufacturer can easily comply with the rules while still pricing spare parts out of reach. Beating the system starts in the showroom. Before buying, download the service manual, Reject units that lock diagnostic codes behind Wi-Fi, and look for physical access to the pump, seals, and spray arms. Choose a stainless steel tub for heat retention, basic physical buttons over fragile touchscreens, and a robust leak protection system. Once the machine is in your kitchen, change how you run it. Stop washing your dishes before the machine does. Scrape the plates, load them with 5 millimeters of clearance, and let the enzymes do their job. Clean the plastic filter cup once a month. Keep the spray arms clear of tall baking sheets, and fill the rinse aid reservoir. If the machine requires your labor to work, make sure it is on your terms. Today, we don't own our appliances, we serve them. The modern dishwasher didn't just become more efficient, it quietly hired you as its essential pre-wash cycle. As design prioritizes paper metrics over practical reality, we are left paying premium prices to do the manual labor ourselves. Is your machine actually saving you time? Share your thoughts in the comments below. If you're tired of products that fail before they should, subscribe. This channel is about exposing the design choices that made everything worse and finding what's still worth buying.